Hello, this is my 2024 Computational Physics Challenge Submission. All of the models were done using numpy, matplotlib, and Python and using Replit. As you can see, all the parameters can be adjusted using the inputs at the start. The first and second are just standard projectile trajectories with no air resistance, but the second is done analytically with an apogee, while the first is numerical. The third one gives you the highest and lowest possible angle trajectories along with the minimum speed trajectory. The fourth gives you the optimal angle trajectory along with your input, which I've pre-inputs here for the sake of speed. Here on the fifth one you get everything in one, along with the bounding parabola, which contains every possible point you could hit with a given speed. On the sixth we get the distance travelled by both the optimal angle and your input. In challenge 7 I created a graph of the ranges of a projectile in its trajectory against time. You can see how for high angles you get a local maximum and minimum, and I created a graph of the actual trajectories for comparison. For challenge 8, I showed the trajectory of a bouncing projectile, and as a mini extension I created an animation for this. In challenge 9 I created a graph of a projectile with air resistance compared to one with no air resistance, and I showed the difference in horizontal velocity independently. Finally, as an extension, I decided to model the trajectory of a projectile shot around the spherical Earth. This involved accounting for the rotation of the Earth and the changes in gravity as the projectile grows distant from the Earth. The white trajectory does not account for the rotation of the Earth, while the red one does. I followed the advice on the slides by creating a rotating coordinate axis. You can see my code here at the end.